Hey guys, welcome back. Let's talk about the autoionization of water, because that's the next thing in our list that we want to talk about. The autoionization of water implies that we're making ions out of water and that it's done by water itself. So water can do this on its own. Water is a great molecule, and I can write it as HOH. And we do that to show that it's an acid and a base together. Now, water has one acidic proton, the one in red, and one OH minus group. That makes water amphiprotic. An amphiprotic substance is one that can either donate or accept a proton. It's also amphoteric because it can act as either an acid or a base. Okay, so amphiprotic is about donating or accepting a proton. Amphoteric is acting as either an acid or a base. In some ways they're the same, in some ways they're not. Okay. And when water donates a proton to become OH minus, it acts as an acid. So it's a proton donor. The OH minus that results is the conjugate base. That means H2O and OH minus are a conjugate acid-base pair. When water accepts a proton to become H3O plus, it acts as a base, proton acceptor. The H2O and H3O plus are then an acid-base pair as well. So again, we can have this HOH reacting with an HOH, and we end up with an OH and the H3O plus. So the H2O donates a proton when it's acting as an ace to become the conjugate base OH minus, and the base H2O accepts that proton to become H3O plus, the conjugate acid. So that's how all of that works. So H2O plus H2O becomes H3O plus an OH minus. Okay, we can also refer to this as H plus H2O. Becoming H plus OH minus, totally equivalent, all right? And of course, if I were to write the K for that, my K is equal to the products, the H plus included because it's aqueous, the OH minus included because it's aqueous, but the H2O does not appear because it's a liquid. And so this is the K for this. And we give this a special letter. It's called KW, and that's because it refers to water. So that's what we're dealing with there. Now, this has a value of 1 times 10 to the minus 14th at 25 degrees C. Does it change when we change temperature? Absolutely it does. Do I expect you to know that that's the value at 25? Sort of, kind of, and we'll talk about that in a few minutes, but it is something you need to be able to work with, and I'll talk to you about how we do that. So that's the autoionization of water, okay? That autoionization of water is going to lead us to a discussion about pH. And I'm going to go ahead and do that here. So pH is a short way to talk about the H plus or H3O plus concentration. pH is equal to the negative log of the H3O plus concentration. So if a solution is neutral, the H plus equals the OH minus, and the pH equals 7. Okay, because it's the square root of 1 times 10 to the minus 14th, which is 1 times 10 to the minus 7th. And if I take the negative log of that, it gives me 7. Okay, so again, KW is 1 times 10 to the minus 14th. If I were to solve, and these are both x's, if I were to solve that x is equal to 1 times 10 to the minus 7th, pH equals the negative log of 1 times 10 to the minus 7th, and that's 7. Okay, they're not always that easy, but that one is. So that's what that's going to be. So if those two are equal, the pH is equal to 7. If the solution is acidic, okay, so if it's an acid, H plus is greater than OH minus, and the pH, therefore, is less than 7. Okay, so acidic things, less than 7 on the pH scale. Basic things, we have an H plus that's less than the OH minus, and therefore the pH is greater than 7. Now, do we often refer to basic things and talk about its pH? We can. It happens, but we don't always. Sometimes we talk about the pOH scale. Now, pOH works exactly the same way that pH does. So it's the negative log of the OH minus concentration. So again, I can take the negative log of the OH minus concentration, and that's equal to the POH. So that little p means negative log. Okay, when we do this for water, we had that 1 times 10 to the minus 14th is equal to the H plus times the OH minus, both of these being x. We found the OH minus, therefore, to be 1 times 10 to the minus 7th. If I take the negative log, 1 times 10 to the minus 7th, that gives me a POH equals 7. And what that means is that at 25 degrees, pH plus POH is equal to 14, which is the negative log of KW. Okay, so that is a relationship that we can work with. Now, if we talk about POH, then when we talk about things being equal, H plus, so when we're talking about POH, H plus equal to OH minus, that's a neutral solution. So I take the negative log of that OH minus, and that POH is 7. If we're talking about something that's an acid, so the H plus is greater than the OH minus, if I take that negative log of the OH minus, pH is going to be less than 7. The POH is going to be greater than 7. And that's because the pH is less than 7. Okay. If we talk about a basic solution where our H plus is less than our OH minus, then the negative log, that POH, is going to be less than 7. And that means our pH, 7 here, less than 7 there, greater than 7 there. Okay, so that's what we're looking at. All right, as an aside, we can measure pH either with a pH paper. Indicators are pH meters. Indicators are one color at a certain pH versus a different color. So as we go through the K for that acid, because it's a weak acid that changes colors, as we go through that K, it changes colors. Okay, so as we take it from the acidic form to the basic form, or the basic form to the acidic form, depending on what indicator we're working with. All right, and this is the part that I love. So this takes us to what we call the fun box. You will find the fun box on your test handouts. So what this tells you, and I'm going to go ahead and write part of this, not the whole thing, but OH minus is equal to 1 times 10 to the minus 14th over the H plus. And I know that going this direction, the H plus is equal to 1 times 10 to the minus 14th over the OH minus. And so I can go from OH minus to H plus. So the arrow going from left to right has an equation above it. That equation applies if we're trying to get from the H plus concentration to the OH minus concentration. Notice that we're using 1 times 10 to the minus 14th to do that because we know what that value is, and that's for Kw. And of course, Kw is related to OH minus and H plus. So we can do that. We can go from H plus to OH minus. Now, if I know what H plus is, then I can calculate the pH by taking the negative log of that H plus. And if I need to get from pH to H plus, I can take 10 to the negative pH, and that equals the H plus concentration. So those are those two equations that you see there. So if we have H plus, we want to go to pH. Sorry, you can't see what I'm pointing at. H plus going to pH, then we have pH equals the negative log of H plus. If I have pH and I want to go to H plus, I have my H plus is equal to 10 to the negative pH. Okay. Now, once I have pH, then I can calculate POH. Once I have POH, I can calculate the OH minus. So how you do this is entirely up to you. But it is really important that you understand that once you have one of these values, my expectation is that you will know what the other four or the other three are, that you will be able to calculate them. Okay, so that should be something that you can do fairly easily. And again, since you're given this fun box, you should be able to do that without any problems. The thing that's going to make you able to do that on test is practicing with it. Okay, so make sure that you've practiced, and you can get between an H plus to an OH minus to a pH to a POH, all four of them. Okay, so you'll see a lot of practice for that in the homeworks that you've been given. All right. Questions, comments, problems on our pH stuff. Okay, I'm going to stop here.